Hey, good morning, guys. All right, so we're going to the next chapter here. It's a long chapter, so I'm going to break it into, I'm going to break it into five parts because so it'll be part one, part two, part three, part four, part five. And the only reason, I'm just thinking I don't want the questions to be too difficult because it's on motors and motor theory. Um, So we'll see. We'll see. Maybe I'll go into four parts. I guess I'll go into four parts. Six questions, and on the last one it'll be seven questions. How about that? Okay. So when we're talking about motors, what is the part of the motor? Okay. So we got all different kinds of motors. We got DC. We got AC. Um, we've got uh, polyphase motors. We've got induction motors. We've got all different polyphase are generally larger size, 5 horse and up or whatever. Your small induction motors are going to be smaller. You got squirrel cage motors, which are one of the most common motors used. You've got a capacitor motor. You've got a start run capacitor motor. So there's all different types of motors, right? But inside of the motor, there's something that turns. What is the part that rotates inside the motor during the operation? Well, if you remember, we took it apart. That part that rotates, that's the armature. The armature spins inside the rotor. And most generally, you have an armature inside the rotor that spins and a stator that has all your windings that is stationary. It doesn't move. Okay, so the armature spins, and that makes that magnetic field based on the space, the little distance between the stator and your when you put current to an AC motor, you put power to it, it energizes the stator, and then when the armature spins, it creates a magnetic field. And a DC motor, you spin it, and the armature has magnets in it, and it creates a magnetic field that goes out through backwards. So it goes out backwards. Um, So the armature is the part that spins in a motor, uh, rotates during operation. The principal reason for developing a brushless DC motor. What does brushless mean? Brushless means we don't have slip rings, we don't have commutators, we don't have brushes. Okay, so why do you think we would build a brushless motor? Well, it would eliminate commutator problems because um, it's where the brushes ride on. So these any movable parts you can eliminate in a motor. Uh, when you squeeze the trigger in a motor and you see it arcing and sparking in, those are brushed motors. Those are ones that have brushes in because that's where it's making its connection. And brushes get dirty. You put a lot of strain on them, they get dirty. You got to clean the brushes. You got to change the brushes. It's a pain in the ass. So you get rid of the brushes in a DC motor, and it's called brushless. And that's what like your little RC cars are. The battery RC cars, they have brushless motors. So it's to eliminate commutator problems. So that's why we make brushless motors. The electrical energy required to produce 1 horsepower of mechanical energy. What was that number? Think about it. There was a number I said of electricity equals 1 horse. Well, in electricity, 746 watts of power equals 1 horse of mechanical energy. Right? 746. What is the wide there is when there's a wide variation in both torque and speed requirements, such as a blower or a hoist. So you got a blower motor or a hoist that picks stuff up and down. What type of motor would you do you think you would use? Okay, do you think you would use? Uh, so series are good for torque and speed requirements to adjust the the to control the speed. A series motor would be best for controlling speed in a anything that has to do with speed requirement. A series motor, because you'd be controlling um, the current of that motor. what is the name of the stationary part? And I just talked about this. What's the stationary part inside that motor housing? So we know that the movable part is the armature. What's the stationary part? The stationary part is the stator. Stator is the stationary part with the windings, the armature. So think about this. You got your armature and you got your windings. If it's a 110 motor, you got one set of windings in there. Okay? If it's a 240 motor, you've got two sets of windings in there. If it's a 243 phase motor, you'll have three sets of windings in there. Okay? So keep that in mind. But the stator is the stationary part. The RPM of a 60 hertz motor with two poles is what? I don't have the, let's put it this way. If you got two poles, each pole is 1800 RPMs. So you got two poles, you've got, two poles is 3600 RPMs. Four poles would be 1800 RPMs. Six poles would be 900 RPMs. So I can't really go through the math with you with this one. Hold on. Let me see if I could just quick find this. Probably not. Leave you hanging on this, but okay. Excuse me. Okay, so I'll go into this a little bit. The RPM is 60 hertz with two poles. So it's not telling me, but it would be, let's say what's 120 times 60? 120 times 60 would be 7,200 divided by two poles. So if it was a 120 volt motor, you would take 120, this is the formula, you would take 120 times 60 hertz and then divide it by how many poles were in that motor. So if it was a two pole motor, you divided two poles, 60 times 120 would give you 7,200, and then divide by two poles, because it says the motor has two poles, which would give you 3,600, and that would be the answer. If it was 7,200 divided by four poles, that would be 1,800. So that's your formula. It's the number of poles equals the voltage times the hertz. The hertz is your frequency, okay, which is always 50 to 60. So we always go to 60 because that's what it's always meant. So 120 times 60 divided by however many poles there are, 1, 2, 3, 4, 5. And if it was a 240 motor, then you would go 240 times the hertz divided by the number of poles, right? And that would tell how fast that's going to be. All right, so getting to the questions. First question, the name of the motor that rotates during the operation. What is the name of the part, the name of the part that rotates during the operation? The stator, the shunt capacitor, C, brushes and commutator, D, armature or rotor. Which one turns? Number 2, the principal reason for developing the brushless DC motor was why? Why did we make a brushless DC motor? A, to eliminate commutator problems. B, improve efficiency. C, improve horsepower, increase horsepower. D, improve airplanes. Number 3, The electrical energy required to produce 1 horse of mechanical energy is what? 476 watts, 647 watts, 746 watts, or D, 864 watts. Number 4, when there is a wide variation in both torque and speed requirements, such as a blower or hoist, what should you use? A, brushless DC motor, B, compound DC motor. You're controlling speed now. C, series DC motor, or D, shunt DC motor. Number 5, the name of the stationary part inside of the motor that produces the magnetic field is what? A, the stator, B, shunt, C, brushes, D, armature. And the RPM of a 60 hertz motor with 2 poles is what? 120 times 60 is 7,200 divided by 2 is 3,600. So it's A, 1,200, B, 2,400, C, 3,600, D, 4,800 RPMs. Okay guys, I got one more video I'm going to put up. This one is going to be part 1. This is for yesterday, and then I'm going to put the part 2 up today, which is for today, because I didn't get one up yesterday. Okay guys, have a good day. Hope everybody's safe. I'll talk to you more in the second video here.